Hello friends, welcome to my channel, that is Hariharan Express channel. Today I will discuss another topic, that is data transfer instructions and addressing modes for load instruction. Two category of instructions I will explain. One is the data transfer instruction and addressing modes for load instruction. Normally data transfer instruction, some data whenever transfer from one component to another component, then how to transfer the data, that is through instruction, means a certain instruction we will consider for data transfer. But think that whenever we consider any data transfer, then what happens, we will use, that is what kind of mnemonics use for data transfer. Normally data transfer we have already discussed, from register to memory, memory to register. But what kind of that is mnemonics are used for data transfer? Very simple way we will discuss that part. It is not so difficult, only remember that part, how data transfer through some certain mnemonics. Okay, so now we will start that work. We will see whenever I go through this data transfer, certain number of mnemonics and certain number of name, the corresponding name we will consider. Okay, so we will see what kind of mnemonics and its corresponding name we will use. Let us consider some certain name and certain mnemonics. Mnemonic. Let's see that. Okay, so let us consider. So for example, load. Okay, for example, load, store. Okay, similarly move and some exchange, input, similarly output. Okay, and push and pop. So different kind of a concept we can consider for this data transfer. Whenever we go through that data transfer, we will see that what kind of a mnemonics we will consider for this data transfer. If you load, very simple way, it is actually load, mnemonic load is LD. Okay, load, if you go through LD, we can use that mnemonic for assembly language. Store for, similarly ST, store for ST. Move, we can use MOV, move. Okay, exchange, XCH, exchange. Okay, that exchange we can use. Similarly, if we go through input output register to transfer our data, we can very simple way use, that is in. Okay, output, similarly out. If that is simple input output register receives data or transfer their data. And if we go through, that is a stack organization, then we insert some data, delete some data. For insert data, that is use push operation, and deleting data we use pop operation. In that case we write, we also use that push. Okay, push data or push mnemonic for this inserting some data into the stack. Similarly, some delete some data, use delete data from stack, use the pop. In that case also we can use pop. So these are the mnemonics are used for data transferring. Okay, that means data transfer from one component to another component, or one data address to another data address. Different names we can use. Based on that also different mnemonics are used. Okay, we just remember that how data transfer from one component to another component, like just process register to memory or memory to process register, and some move instruction has been used in computers, that multiple CPU register to design a transfer from one register to another. Okay. Also that is that data transfer between CPU register to memory, or between memory to memory, or register to register. Whenever you go through this exchange data also transfer. Okay. If you go through exchange of data, exchange instruction swap information between two register. Okay. Or a register, another is a memory word, like this kind of concept also we can use for exchange. Okay. And sometimes what happens, input output instruction transfer data also among processor register also use through different input output terminal or devices, input output devices through that. And that is also some mnemonic words also use, input, in and out. These are the things I have already told, that is push and pop point of view, that is use some stack, memory stack, register or memory stack we can use. For that reason push and pop mnemonics we use. These are the, that is a typical data transfer point of view, we use this one. Similarly another part is addressing modes for load instruction. So load instruction, what kind of addressing modes are used for load instruction. In this case also we can also use another way. What are the different modes we have already discussed in the last lecture, that is different modes, how use the different kind of addresses, or different kind of address defined, and its corresponding what are the that is assembly language or assembly instruction, that is also used. And when it data transfer through certain register, then how it is used, that kind of things we will also discuss here now. Okay. Now we see very simple way, I will that is write how different data instruction that is used through mode. I will show you also, we can do. Different data also we can use. Okay. Let's see what kind of right. If we go through modes, many modes are there, we have already discussed that part, but still that is some modes also we can use a very simple way. Okay. What are the modes, what is corresponding, and that is a the assembly convention or assembly instruction, then a register, that is a transfer. Okay. We will see that is a, here is a assembly convention, and register or transfer. Okay, register transfer. Similarly, so different address mode are there, just like you go through direct address mode, one okay, direct address mode. Similarly indirect address mode. Okay. Similarly relative address mode, okay, or immediate address mode, or index addressing mode. Similarly register addressing mode, register direct, actually one thing you can register direct address mode. Next register indirect address mode, auto increment, okay, auto increment or auto decrement, different words. Okay. These are the that is a mode. Then what kind of assembly convention or assembly instruction we will use. You will see very simple way the assembly instruction we will use. What are those? That is a LD, suppose direct address. Direct address is very simple, LD, then it is load direct LD or ADR. Direct address we can use in this way. Okay. Next, whenever a direct address is used, then what happens? Simple this address is there. So address collected from memory and store in register. So in that case what happens? Very simple way we can write memory, that is ADR. ADR is direct address. The address collected from memory store in a register. If we go through direct address in this way, load address means collect data through this address, store in a accumulator. Okay, in this way. If we go through indirect, similarly same case also we can, but simple one concept is there at the rate ADR. In this way we can write load at the rate ADR, means some address we have to define. In this case what happens? I have already told that is two references. If indirect address we go through two reference. Okay, if we go through two references, in this also we can define ADR. In this one reference, again another reference. If a number of references is there, then we go through this indirect address. Okay, another way, relative address. If you go through relative address, then what happens? Load. Actually you go through all our load, because very simple way load, since it is mentioned load instruction, we only use load instruction. So relative address dollar, that is ADR. Okay, dollar ADR. In this case what happens? SC, very simple way, SC. Here what happens? We will go through relative from program counter, through program counter we go through that. That is a PC plus ADR. Okay, PC plus ADR. I mean PC plus address data and store collect from memory, store in a register. Okay, collect from memory, store in a register. Similarly, if you go through immediate operand means a very that is a direct data. Okay, number, direct number. We have already discussed how immediate that is a instruction generated or in immediate address is mode used for direct data. Okay, so in this case also load, and since it is a direct number, means a direct value, no need regarding on operand, direct value we can also use. Okay, that is a NBR. Okay, load NBR. In this case what happens? How to make? That is a direct number NBR, direct number load into the accumulator, direct transfer to the accumulator. Okay, next index. If we go through index, similarly all our load LD we can put index. Index means here what happens? Address register of X. Okay, address register of X, like this. Okay, in that case what happens? Similarly SC, and first is address register, because index register, address register, and here also defining this through memory, address register plus X. Okay, plus XR, we can write XR register, one address collect from register, XR is register. Okay, index register, actually it is defined, is X for defined for index register plus some address from memory and transfer to SC. Similarly, if we go to register direct, very simple, register direct R1. Okay, that means R1 register content direct transfer to SC, very simple. Similarly, if we go through, that is register indirect is just one, direct is no need, direct data operand we can use. If indirect, some that is a brushes we just mentioned here. Similarly, we know that indirect means some memory register we can use in this way. Okay, memory register. Since register, you see some difference between direct data, indirect data, it's a different. So register, simple way. If that is indirect, then it is collected from the memory within certain one process. If we go through memory direct, double process is required, but register single process is required. Okay. So in this way we can define that is a register indirect address. Okay. Next is similarly if we go through auto increment or auto decrement, means load R1 plus means auto increment. Then what happens here? SC, what to write? SC, here write MR1 because R1 contained there is a transfer to SC. Here R1, you see where R1 is R1 plus 1. Okay, where R1 is R1 plus 1 because it is increasing order. Okay, where R1 is R1 plus 1. Increment data is here that transfer to accumulator. Similarly, if we go through auto decrement, that means R1 minus. In this case, what happens? Here similarly R1, okay, here R1 is equal to R1 minus 1, okay, R1 minus 1. In this way we transfer the data through load instruction. Very simply, all assembly convention we just use load instruction. How different load instruction are used for a different kind of mode. Maybe direct address, maybe indirect address, maybe relative address, immediate address, index address, register direct address or register indirect address, auto increment or auto decrement. Since it can be used for others also. Since it is very standard mode, so we use this part. Okay, this is the basic concept regarding on load instruction, how register transfer use, assembly convention use, and also that is another part how that is other data. Whenever go through load instruction defined in this way, very simple way, and register transfer also defined in this way. Okay, this is the part of addressing modes for load instruction. Okay, so I complete this part, that is a data transfer instruction and addressing modes for load instruction. Okay, thanks to watch my videos. Thanks to all. Please share my channel or please subscribe my channel and like it. If any comments you want to give, then please comment on my videos and also channel. Okay, thanks to all. Thanks to see these videos. Okay, thanks.